Hello students, welcome back to our Bridge Course online classes. In the previous video, we have discussed about the meaning of science, the various branches of science, the definition of physics, and the various fields in the physics. And also, we have discussed in detail the major discoveries in the field of physics. In this video, we are going to discuss what is a physical quantity, various physical quantities, types of physical quantities, definition of scalar, definition of a vector, characteristics of scalars, characteristics of vectors, comparison between scalars and vectors, and lastly, resolution of a vector. So let us start the video. Firstly, let us know what is a physical quantity. A quantity, anything that can be measured and expressed in terms of a number, is called as physical quantity. For example, as you can see in the image, a lady is measuring the height of a kid so that she can measure the height of the kid and express in terms of the number. Hence, height is a physical quantity. Why? Because it can be measured and expressed in terms of a number. You can tell height in a number. Hence, height is a physical quantity. The second example is the temperature of the surrounding. As you can see in the picture, you can measure the temperature of a laboratory or surrounding using a thermometer. This thermometer is called as laboratory thermometer. In this thermometer, you can see the values. For example, it is showing the temperature of the surrounding as 20 degrees Celsius. Hence, temperature is measured in a number known as 20. Hence, the temperature is a physical quantity, which means that anything that can be measured and expressed in terms of number is all known as a physical quantity. The examples of physical quantity are mass, height, length, temperature, etc. So, is it clear? So, physical quantity means anything that can be measured and expressed in terms of a numerical value. Here, I have listed various physical quantities. Those are length, mass, time, electric current, temperature, amount of substance, luminous intensity, force, velocity, speed, momentum, torque, impulsive force, and power. These are all the various physical quantities. In the left side, I have mentioned length, mass, time, etc. So these are the fundamental physical quantities, which means that these physical quantities are independent of each other. They do not depend on any other physical quantities. Hence, these physical quantities on the left side are known as fundamental or base physical quantities. On the right side, I have mentioned force, velocity, speed, etc. So these physical quantities are known as derived physical quantity because These derived physical quantities are dependent on the left side physical quantities, which means that the derived physical quantities are dependent on the fundamental physical quantity. Hence, those are called as derived because they are derived from the fundamental physical quantities. So, there are two types. One is fundamental physical quantity, which are independent, and the second one is derived, which are dependent on other physical quantity. They are dependent on fundamental physical quantities. So these are the various physical quantities. Now let us move to the types of physical quantities. These categories are classified based on the magnitude and direction of a physical quantity. This classification includes two categories. Those are scalars and vectors. What is a scalar quantity? A quantity which is having only magnitude. In the picture, you can observe that the clock is showing a time as 1 am. Here, time is measured and expressed in terms of a number. Hence, 1 is a number, isn't it? So, 1 is the number or the value. It is also known as magnitude. So, time is having only a number. It is having only magnitude. Hence, time is a quantity which is having only magnitude. So, such quantities which are having only magnitude are called as scalar quantities. The another object shows that the mass of it is 1 kg. Here 1 is the magnitude, 1 is the value, and kg is the unit of the mass. Hence, the mass is having only value. It is having only number. Hence, mass is also an example for scalar quantity. Also, the temperature is showing 20 degrees Celsius or something else. Hence, 20 is the number. 20 is the magnitude. Hence, temperature is also an example for scalar quantity. So, students, a quantity which is having only magnitude are called as scalar quantities. The example for scalar quantity is length, speed, work, mass, density, etc. So these are the example for scalar quantity. Now let us move to the definition of vector. What is a vector? A quantity which is having both magnitude and direction. Here, the quantity not only exhibits magnitude, it not only exhibits value, but it is having a particular direction. Those physical quantities are known as vectors. So, vector is nothing but a physical quantity. You can measure it and express in terms of number, which is having both magnitude as well as direction. Such quantities are known as vectors. The example for vector are displacement, force, torque, momentum, etc. So you can see in the image, in the first image, you are reading a nameplate as 5 meters long, which is a scalar. 5 is the magnitude, meter is the unit of the measurement. In the other hand, the vector is having a nameplate as 5 meters towards east. Here, vector is having magnitude of 5, a unit known as meter, and also a particular direction as east. So the difference between a scalar and vector is a particular direction. If the quantity does not have any particular direction but is having a only magnitude, then we call it as scalar. If the quantity is having both magnitude as well as direction, then the physical quantity is known as vector. So the major difference between scalar and vector is the direction. In the second image, you can observe that the hiker is walking with the velocity, with the speed of 3 meter per hour. It becomes speed if the hiker does not have any particular direction. The speed is an example for scalar because speed is having only magnitude but no direction. This speed becomes velocity when the hiker is walking with the velocity of 3 meter per second towards south. If there is a particular direction, then the physical quantity becomes vector, which means a velocity. Velocity is an example for vector. Vector is having both magnitude and direction. Here, the velocity of the person is 3 meter per hour towards south. Here, velocity is having a magnitude of 3 meter per hour is the unit and the direction is towards the south. Now let us move to the characteristics of scalars. A scalar is having only magnitude. The second characteristic is that the scalar requires two things. Those are, first one is a value, a magnitude. The second requirement is an unit. For example, the mass of an object is 5 kg. Here, magnitude of the mass is 5, is a value, isn't it? And unit is the kilogram. So the scalar is having a particular magnitude and a unit. So these are the requirements of a scalar. Now let us move to the characteristics of vectors. Vector possesses both magnitude as well as direction. The second characteristic is that they do not obey the ordinary laws of algebra. The laws of algebra, addition, subtraction, multiplication and division, are not applicable to the vector addition, subtraction, multiplication and division. The third characteristic of vector is that they change if there is a change in magnitude or direction or both are changed. For example, the force applied on an object is 80 Newton. Here 80 is the magnitude, Newton is the unit and direction in which the force applied is specified. Say it is towards south. If I change the value 80 to 70, then the value of vector changes. If I change the direction of south into north, then the value of vector changes. If both the value means magnitude and direction are changed, then also the vector is changed. These are the three characteristics of vectors. Now let us move towards the difference between scalars and vectors. The definition of a scalar is a quantity having only magnitude. A vector is a quantity which is having both magnitude as well as direction. The second difference is the direction. If there is no direction, then it is called as a scalar. Yes, there is a particular direction, then it is a vector quantity. The third difference is that a scalar is specified by a number, which means a magnitude as well as a unit. But a vector is specified by three requirements. Those are a number, a magnitude, and a direction with its unit. So the requirements for a vector quantity are: first one is a magnitude, second one is the direction of the quantity, and third one is the vector. Third one is a unit of that vector. Now the fourth difference is that symbol of the quantity. Scalar is represented by the symbol of a quantity. For example, mass of the substance is a scalar quantity. This is represented by m. M means mass, isn't it? So, the quantity symbol is given by the letter of the physical quantity. First letter of the physical quantity. But if you are mentioning an arrow above the letter, then it becomes a vector. Hence, a vector is represented by a quantity symbol in uppercase and an arrow sign above it. The last difference between the two scalars and vectors is the examples given for scalar and vectors. Mass and temperature are the two examples I have mentioned here for the scalars. Mass is the physical quantity which is having only magnitude, which does not depend on the direction. If you change the direction, then the mass does not change. The mass remains constant. Hence, mass is having only magnitude and hence it is a scalar quantity. Similarly, temperature is also a scalar which is having only magnitude. If you vary the direction of the measurement, then the value of temperature remains constant. It does not depend on the direction. Hence, temperature is also a scalar quantity. The examples given for vectors are velocity and acceleration. Velocity is nothing but speed of the object with a particular direction. Speed is an example for scalar. If you add speed with a direction, then it becomes velocity. Hence, velocity is having both magnitude and direction is a vector quantity. Similarly, acceleration is the change in velocity of the object. Here, velocity is having a particular direction and hence that direction comes to the value of acceleration. Therefore, acceleration is also having a particular direction with a magnitude. So these are the examples for vectors. So these are the 5 differences between scalars and vectors. Now let us move to the last concept, that is resolution of a vector. What is resolution of a vector? It is nothing but splitting up of a single vector into two or more vectors in different directions. So this single vector is equals to the vectors which are produced from the splitting of the vector, which means that the different vectors produced give a similar effect as the effect given by a single vector itself. The vectors formed after splitting are called as component vectors. If you split a vector into two components, then the two components are known as component vectors. You can understand the resolution in the image clearly. So here is a vector R with the arrow mark. This vector R is making an angle theta with the x-axis. Here the R vector is going to split into two vectors. Those are R cos theta and R sin theta. R cos theta is going to split along x-axis and R sin theta is going to split along y-axis. So this is the resolution of a vector R. You are splitting one vector R into two vectors. Those are R cos theta and R sin theta. So how you are going to split these vectors? The splitting of vectors is dependent on the angle theta. So where there is a theta, that adjacent right side is written as R cos theta. On the contrary, where there is no angle theta, you must write R sin theta. So this is the splitting of vectors known as resolution of vector. In this video, we have discussed what is a physical quantity. So anything that can be measured and expressed in terms of number is called physical quantity. We have also discussed various physical quantities. Those are fundamental and derived physical quantities. Also, we have defined scalars and vectors, types of vectors depending upon the magnitude and direction. Also, we have discussed the characteristics of scalars and vectors. And also, we have compared the scalars and vector. And lastly, we have discussed the resolution, the splitting up of the vector into two or more vectors. In the next video, I will discuss the types of vectors in detail. Thank you.